This lesson is going to be split into two parts. We're going to first look into magnitude, and then the second part will look into the unit vector more closely. So we've talked about magnitude as an essential part of defining vectors. So vectors have a direction and a magnitude. So how do we find this magnitude, this size of the vector? We've talked about the notation, but not the formula. Well, the formula is not actually new. It's similar to the formula that you use for the distance between coordinates. It's the technically Pythagoras' formula, and you can easily figure out the proof as to why we use Pythagoras' formula for this. So the notation, we use these double bars, and if my vector has components a1, a2, then the magnitude will be the square root of the coefficient of the I component squared plus the coefficient of the j component squared. So quite easy to do. Now, if you have a direction vector, AB, so not starting from the origin, well, you can find the actual result of this first, which will give you like a normal vector here, and then you find the process similarly, or you can take the distance, the difference between them, square it, and then the difference again, square it. So what you're technically doing here is actually finding the component form or the components of vector AB, and then finding the magnitude. And for 3D it extends the same way. It's just that you have a third component to deal with here. So fairly simple, nothing new, but we're going to go through the worked examples just to make sure we've covered all the bases and all the type of questions you're going to face. So given these coordinates, I need to find the magnitude. So for part A, quite simple. You're just taking the square root of 2 squared plus negative 6 squared. Obviously the negative won't matter, so you can ignore it if you're writing on a calculator, or you can keep it in there. So this will simplify to 2 root 10. For part B, be careful not to do the magnitude of A and then the magnitude of B, and then multiplying by 2 and so on. So don't do the arithmetics here separately, or the algebra. Remember back in the first lesson where we've talked about how the magnitude, when we're adding vectors, it doesn't mean that their magnitude also adds. So just keep that in mind. So the first thing you need to do is actually find the result of this first, and then you find the magnitude of it. So I have 2 lots of vector A, so 2 and minus 6. And I'm taking away, let's do a plus, minus 3 of minus 3 and minus 5. So as a result, you can go through the process. This will give me 13 and 3. So I need to find the magnitude of this vector, which is 13 squared plus 3 squared, root 178. So for this, slightly different. So I have a vector C and a vector D, and I need a K value for K such that the magnitude of vector C is double the magnitude of vector D. So we start setting it up. So I know vector C is going to be negative 7 squared plus 6 squared. So that's going to give me root 85. And then for D, we can do the same thing. K squared plus 2k squared. Be careful with the squaring here. When I simplify this, I get a 4k squared. Again, careful with the simplification. This will give me a 5k squared, which again simplifies to a k root 5. Now, combining these together, I need a k such that this will be double the magnitude here. So root 85 should be equal to 2 lots of the magnitude of d, and it's just a matter of solving for k. So if I take root 5 to the other side, I end up with 85/5, which will give me a root 17. Keep in mind you're doing a plus minus here, and then you're dividing by 2. So k will be equal to plus minus root 17/2. Always remember the plus minus, especially that k is just a real number. You're taking a square root, so you shouldn't eliminate one of the roots. So it should have been somewhere here. The magnitude itself, the reason we haven't mentioned it here is that the magnitude itself is positive because you're talking about the size. But the reason we're adding it here is because we're defining k, which is a real number. It's not the magnitude. But the way we found k is through magnitude. So that's why we need to bring back the plus minus. For this example, it's going back to geometry and try and think of how we prove something is a right angle triangle. And that would be through Pythagoras. So if I can prove that it fits Pythagoras' theorem, then we have a right angle triangle. So how do you prove that? Well, remember that these are points that you have and not vectors. If the length of these, the distance between the points, if the length match Pythagoras' equation, then we have a right angle triangle. Well, so pretend, it might not be an accurate representation of the triangle, but these are the points. I actually need the magnitude here of between each point. Well, to find the magnitude, you first need to find the vector itself and then find the magnitude. Now, the direction here will not matter because we're focusing on the magnitude. So what I'm going to do, I just want A to B. I want the distance A to B, which we know is OB minus OA. So this will be 0, 4, 1, and minus 1, minus 1, minus 2. And that will give me 1, negative 1, sorry, 5, and 3. So this will be AB. Now, if I want the magnitude of A to B, I could have done B to A. The magnitude will still be the same. It's just that the direction was going to be different, but I'm concerned about the magnitude. So the magnitude of A to B is going to be the square root of negative 1 squared plus 5 squared plus 3 squared, which will give me root 35. Now, I'll do the same thing for all of them, A to C and B to C. So we're looking at every single length. Again, doesn't matter if you're doing C to A, C to B. We're focused on the magnitude, not the direction. I'm just gonna skip the extra steps. This should give you 1, 3, and 4, and BC should be 2, minus 2, and 1. The magnitude of AC would be root 26, and keep it as root because we're not done with the question yet. And the magnitude of BC is 3. So I have 3, root 26, root 35, and now I want to see, does it fit Pythagoras? Well, for Pythagoras, we need to check, is the longest length will be the hypotenuse, so we'll assume this is the hypotenuse. If squaring the hypotenuse gives you the same result as taking the other two values squared, and it does, so you have 9 plus 26, which gives you 35, and this is 35. So you can write a tiny conclusion here. It fits the Pythagoras' theorem, therefore it is a right angle triangle.